All right, so today we're going to be talking about cash flows, and I had a couple of people asking questions from the homework related to cash flows, and I think what we cover in class today will probably address your uncertainties on that. Do you have a question?
This is actually about the thing that you were just talking about, where you're going. Are you going to go to the Mount Block Museum for those World War I?
I don't know, maybe should I?
I don't know. I don't know if there's a museum or not. I assume there will be because there's a big battle there.
I haven't heard of that battle, but it's going to be raining while I'm there, so museums may be high on the list. Yeah.
You know if this room's going to be open during your class times next week?
Yes, this room will be open next week. So if you want to come here to watch the video or study or whatever, that's available. Yeah.
There was another question about the previous thing, if you don't mind.
Go ahead.
I'm a runner, so I'm interested in that stuff. How many miles is that? Because that's a lot.
Yeah, that one's 61 miles. It's the shortest race I'm doing this year.
And the longest I've done is a half marathon. That's
well, calling it a running race is probably a misnomer. It's mostly hiking, so that makes it easier. Yeah. All right. So next week, I won't be taking attendance during, obviously, your recorded videos. You can watch those anytime you want. Hey, watch them all today, and then you're done for next week. Question?
There's also
Let's talk about running after. I can see if I get started, I won't stop. That's the problem. Because I want to talk about running all day long, but I need to talk about cash flow. Yeah. All right. So one last reminder about your homework assignments. The homework 1 is due on Monday by noon, and then homework 2 is due Wednesday of week after next, so September 6th. Okay. So I want to just revisit the idea of weighted averages because my impression was that threw a few people off during the in-class exercise on Wednesday. So here's a simplified example. And in this example, rather than talking about the percent of funds that are earning a certain interest rate, this is going to just illustrate the same weighted average concept using how many dollars you have at what interest rate. So the idea of a weighted average is that you want to know how much of the thing is at a certain condition. So just to illustrate, if you have two accounts, one account that pays 10% interest and another one that pays 2% interest, you obviously want to keep most of the money at the account that's paying the higher interest rate. So in this example, you're keeping $5,000 in account A and $1,250 in account B. So the weighted average interest rate is not just going to be 10 plus 2 divided by 2. That would be the simple average, but the weighted average, you can see, is you multiply the amount by the interest rate for both account A and account B, and then divide by the total amount of money. So the weighted average in this case is 8.4% is your weighted average interest rate because you have more of the money in the account that pays higher interest. So that's just the idea of a weighted average. Don't be thrown off by the formula. Just maybe think about it logically. You have to know how much of the thing is where, and then you can either have it be a percent of the total that is in a certain account, or it can be the number of dollars that's in each certain account, and then divided by the total number of dollars. Okay, so I just wanted to reinforce the idea of weighted average with one other example. So now, with that, let's talk about cash flow terms and diagrams. Somebody's having a bad day. All right, so inflows, from our perspective, are revenues. That has a lot of different names. Sometimes they're called receipts or incomes. If you have a business and you make some sort of a change that decreases your costs, that's also considered an inflow. Like if you close the window because you realized leaving it open all night long was increasing your heating bill, the act of closing your window to save money on your heating bill would be considered having generated an inflow. And there's other things we can do. We'll be talking about like investments that reduce your costs, but those investments are an outflow, but then the effect of the investments is considered an inflow.
Do interest payments received count as cash inflow?
Sure, yeah, if you're getting interest, then that's an inflow.
So basically inflows just how much you make at a job.
It's money you're getting.
Okay, that's,
You don't even have to be making it. Like, if you think about landlords, they don't make their money. Sometimes they're just rent seeking, as it's called. So it's money you get. It could be, money the government gives you, money you get. Outflows, sometimes they're called disbursements, costs, expenses. If you have to pay taxes on things, that's an outflow. So the minus sign, from your perspective, the money going out is an outflow. It's negative. So the net would be the difference between the two. Inflows minus outflows. If we're thinking about it as revenue minus expenses, then the net cash flow is another word for profit. But all it just means in the sense of keeping track of the ins and the outs is the difference between the inflows and the outflows. Now, unless stated otherwise, through the entire semester and also out there in the world, the typical convention and assumption is what's called the end of period assumption. And that is that inflows and outflows occur at the end of some time interval. So, for example, if I put money into the bank today, $100 into the bank, and they pay monthly interest, they're not going to pay me the interest today. They're going to pay me the interest at the end of the period. And so the end of period assumption says that, if there's some compounding that occurs, it occurs at the end of a given period. So the same thing is true for inflows as well. If you are working, in most cases, your employer will pay you at the end of some period. They're not prepaying at the beginning of a period. So we'll circle back to this end of period assumption when we're translating statements into diagrams, but I wanted to raise it now since we're going through some definitions. Now, we make cash flow diagrams because it's a lot faster to look at a diagram and understand what's happening than interpreting the English language statement that diagram may represent. A cash flow diagram is a way of really quickly and concisely conveying information. And clearly, there's no confusion when it's a cash flow diagram in the same way that people sometimes will get hung up on grammar or the interpretation of words. Cash flow diagrams are a lot more absolute. So just to give you an example of such a statement, you borrow $10,000 at 6% compounded annually to be paid back after 5 years. How much must be repaid? So that statement can be summarized by a diagram, and it'll be a lot easier to just look at the diagram and know what's happening than it would be to read the English language and think about it and interpret it. And so the way that we could translate that statement into the diagram is our convention is anytime you're getting money, we draw it as an up arrow. And anytime you are paying or dispersing or losing money, that's a down arrow. So inflows are up, outflows are down. So if you borrow $10,000, that means you're getting money at time zero. Now it didn't say like at time zero in the statement, but that's the default assumption, is that the first transaction that is described occurs at zero. That is now. Zero is the present. 1 is one period in the future from the present. So if you're doing this problem in periods of years, then 1 would be 1 year from 0, which is today. So you borrow $10,000, so that means you get the money now, and you're paying it back after 5 years. So in 5 periods, in this case the periods are years, we've got an arrow down because you have to pay it back to whoever you borrowed it from. And you'll notice that it's a dashed line in the case of the outflow because we haven't calculated the amount yet. So that's an unknown quantity. So we also re-emphasize that with the question marks after the label. So P stands for present, F stands for the future, and so you can see that, like, you can glance at this diagram, and once you know how to interpret them, it's a lot faster than all of these characters and words and the meanings behind it. This just means find the value of f 5 years in the period, five periods in the future when the interest rate is 6% per period. So it doesn't matter if this is months or years or decades. I equals 6% means 6% per period when it's written above a cash flow diagram. And the duration of a year is from 0 to 1. So the first year is a period of time that goes from 0 to 1. The second year goes from 1 to 2. The third year goes from 2 to 3. So these vertical lines here represent just an instant in time, but the space between the vertical lines represents a period of time. So like this hash mark here at 4 means 4 periods after today. But then the space between 4 and 5 is the 4th year. So sometimes you have to even just count. Like this arrow, how many years in the future is it from now? You count over 1, 2, 3, 4, 5 years from the present.
If this account accrues interest, and the interest is counted in inflow, why isn't the interest payment represented as arrows on the diagram?
Well, you've gotten the money now, and you're not going to do any other transaction. You're not going to be paying anyone. Even though the money that you've borrowed is accumulating interest, you pay the interest and the principal back to them as a lump sum at the end of the 5th year.
Okay, so it only counts for external transactions?
That's right. Yeah, it's when you actually give them the money.
So just to clarify, say that it was an account that was compounded like monthly. Would each time period then be a month?
It depends on if they're saying in the problem statement that it's 6% per month. But yes,
Okay.
like if this said, let's say, I'll change the language back. Let me just say, phrase it differently. You borrow $100,000 at 6% per month to be paid back after 5 months. Then that diagram would look the same as it looks now. Okay, so I know the first time you see one, maybe it seems really unfamiliar, but by the end of the semester, you'll be whipping these out like it's nothing. I mean, it'll be trivial for sure. So let's talk about the symbols and abbreviations that we use, both in cash flow diagrams, but also when translating problem statements into the calculations you do on paper. So I refers to an interest rate per period. And in this statement, each period is a year. N is the number of periods, and most of the time it'll be years in the problems that I give you, but sometimes I'll be tricky and I'll say, for example, you have to pay back a loan in 3 years and that the interest compounds monthly. And if I said that, then N would be 36, because you take the 3 years and multiply it by the number of months per year, which is 12. So you need to really carefully read and see, how frequently does the interest compound? Because that's going to set what you use as N. And here's another thing. If I said it's 12% nominal annual interest compounded monthly, then the I that you use in the problem statement would be 0.01. Because it's 1% per month if it's 12% nominal annual interest. Do you remember on Wednesday we talked about nominal versus effective? What's the other word I said you could remember when I say nominal? It's not really. 12% nominal interest is not really 12% interest per year. Because the effective interest rate, if you take into account the interest on top of interest, would be higher than that. So let me just write this on the whiteboard so that there's no confusion. 12% nominal annual interest compounded monthly If you had some problem that said that, then what you would use in your calculations, I would be 0.01, because you divide the annual interest rate by the number of periods per year that the compounding occurs. So I'll give you some problems like that in the in-class exercise so that you get the hang of it before you get to the homeworks and before you get to the exams.
So you would divide 12% by what again?
12 periods per year. Yeah, so it would be 0.12 divided by 12, so that's where you get 0.01, because it's 12% per year, 12 periods per year, so then the interest rate per period would be 0.01. Okay, but the symbols here for this statement, it says you borrow $10,000 at 6%. There's going to be a lot of things that are implied that aren't explicitly stated that you should just understand it means now. So for example, if they don't tell you when you borrowed the money, well, does that mean you borrowed it in year 5? Does it mean you borrowed it in year 6? In the absence of any other information, it means you borrowed it now. That the beginning transaction is where we are setting 0. The start of our problem at the first transaction that occurs. Okay, so P means present value, $10,000. The interest rate here, 6% per year. So I is 6%, or if you put it into an equation, you need to change that to 0.06. N equals 5 years, F equals unknown, because that's what we're finding. How much must be repaid? A point estimate is when you're given the exact amount. So this is an illustration of an annual series. Sometimes it's called a uniform annual series, where it's the same amount every year. So I don't have to write 150,000 6 times, because it's always the same amount. You know, just by inspection, by looking at it, you can see those arrows appear to be the same length. And if the amount is centered above a group of arrows that appear to be the same length, you can infer from that that they're all the same amount. So what this would mean is every year for 6 years, you get $150,000. And it occurs at the end of the period. So the end of period assumption is that at the end of every year. So you're not getting it at the beginning of the first year. The end of period assumption means it happens at the end of the first period, the end of the second period, and so on. So a point estimate is when you know the exact amount. Sometimes you will, sometimes you won't. Like if you have a contract with someone and they're reliable, and it says that you will definitely earn $150,000 at the end of each year, then it may be that. If you operate a business where there's some uncertainty, like you don't know how much your customers are going to buy, but your best guess is it could be between $135,000 and $150,000 per year, then this is a way of expressing a range estimate. Rather than having like an arrowhead that stops at a point, you could have these dashed lines that represents the lower bound and the upper bound. Much later in the semester, after Thanksgiving, we'll spend some time talking more about risk and uncertainty and ways that we can do calculations to cover our bases and understand the range of possibilities when there's uncertainty. This is just how you represent it graphically. Okay, so here's some suggestions on how to draw good cash flow diagrams. First of all, when you are translating an English language statement into a cash flow diagram, you need to put on the appropriate labels. P means a present value. F means a single future value. And A is an annual series where it's all equal amounts. So the reason why I haven't labeled these as a bunch of different F's is because it's all the same amount. These are future amounts, You know, this is saying that you get $4,100 at the end of the third year, the fourth year, the fifth year, and so on through the end of the ninth year. That every period you're getting $4,100. And it's saying, how much is that worth as a lump sum today? In other words, if you were going to get the same economically equivalent value as a lump sum, how much would that be today instead of taking a series of payments in the future if 4% is what's called the discount rate? Sometimes you'll hear it called the interest rate, but the discount rate just means that if you're moving money from the future backwards to the present, the amounts get smaller. Because in the same way that if you put money in the bank, it grows larger as you move into the future. If you're taking future amounts and you want to know the equivalent economic value in the present, then the amounts are smaller. So amounts get bigger in the future, they get smaller as you move backwards through time. So here, this is just saying, what's the present value? Has anybody heard, like, for the lottery, when they say the lottery is $20 million, that's only if you take it over time. You know, like somebody who wins the lottery and they say, hey, you're a $20 million winner. What that would mean, for example, is that they get $20 million spread out over a bunch of years. Maybe that would be $1 million now, and then another $1 million 1 year from now, and then another $1 million at the end of year 2. And so 19 years in the future, plus $1 million now, add it all together, and that's $20 million. But if they wanted a lump sum, it's always much smaller than the advertised value of the jackpot. I mean, I'd still take it, obviously, but the magnitude of the money is smaller because what they're doing is they're taking the time value of money into account, saying if you're going to take a lump sum, it should be smaller than the sum of all the dollars in the future. Okay, so A is an annual series, sometimes also called a uniform annual series, where the length of the arrow should be the same. Some other tips. So here's another cash flow diagram. Now, this would be maybe something that you'd be given before you start doing your calculations. So you'll notice that this doesn't have the labels annotated. And that's because I expect you to write the annotations on it before you start solving the problem. So you just have to see, like, okay, this is an annual series because they're all the same length. The text above it is centered, so that appears to be a uniform annual series. But this obviously is not a uniform annual series. This is what's called a gradient, where the amount keeps getting larger or smaller by a fixed quantity with each successive year. So you could see for this one, your outflow is increasing by 1,000 each year. So that's an example of a gradient. But the thing is that the lengths of the arrow should approximately indicate what's a larger amount and what's a smaller amount. Like, it doesn't have to be exactly scaled. Like, I don't expect you to get out a ruler and make $11,000 11 millimeters. And then $5,000 doesn't have to be exactly 5 millimeters. You know, like, you're not going to get points deducted if the lengths aren't precisely the correct scaling. But, you know, it's better if a long arrow represents a big amount and a short arrow represents a smaller amount. That'll just make it easier for you and everybody else who's looking at the cash flow diagrams that you sketch. So they should be directionally accurate, if not perfectly to scale. Somewhere on the diagram, you should write the interest rate. So here you can see, just based on where things were, the interest rate was above the cash flow diagram. Here, the interest rate was above the cash flow diagram. There's no real right or wrong, as long as it's clear what interest rate applies, and it's somewhere on the diagram. Any unknown should be represented with a dashed line. Like you can see here, that means we're trying to figure out what would be the present value equivalent, and emphasized with the question mark next to the label. Now, this is one that I always get somebody on the midterm exam who makes the mistake. So I'm hoping this year will be the exception. I hope nobody makes the mistake on the exam. Just how long the cash flow diagram is doesn't tell you how many years there are. It doesn't tell you n in the calculations. So like this annual series, it's not 18 payments just because the cash flow diagram has 18 years drawn on it. There's 1, 2, 3, 4, 5, 6, 7. So here, the number of annual payments is different from the length of the cash flow diagram. So don't just be thrown off by the fact that you see the number 18 written on the cash flow diagram and assume that that's n. It may or may not be. It's good if the distance between years on your diagram is pretty consistent. It's good if you put the year label on there. No, I'll say it's required. Don't make me write on your exam the number of years. You should put these like 1, 2, 3, 4 labeling. And set it slightly to the left of the tick mark because sometimes the number is going to need to go downward. So if I put the number right below the tick mark, then that downward arrow would be going through the year annotation and it would be more difficult to read. So if you just set it to the side, then that won't be a problem. So those are some initial best practices in preparing cash flow diagrams. Does anybody have questions about this? Okay. I have an in-class exercise for you. Let me hand that out. Okay, you received $10,000. That means the arrow is up. You're getting $10,000. And then when you repay it, the arrow is down because from your perspective, it's an outflow when you're repaying money to the bank. So you'll notice that the 10,000 arrow is longer than the 3,300 arrows. It's not exactly proportionally longer, but it's longer, and that's good enough. The labels are on there. Okay, so for the second one, there's two different perspectives. There's your perspective and the bank's perspective. So here's the solution to 3 and 4. Okay, so problem 5 is kind of the reach question. It's the one that, we've covered it a little bit, but not quite all the way. So you're kind of figuring it out a little bit on your own. I mean, that's basically what you're going to be doing all the time after you graduate. So we try and give you just little tastes of that when you're in school, like figuring something out on your own, finding it in the book, even if it hasn't been discussed in class. Occasionally, I'll give you a problem like that. So here, what we've got is you get 10,000 now, and then you get 5,000 in 1 year. And the applicable interest rate is 6%. So you're going to have to pay something back at the end of 5 years from now. How much do you have to pay? So you've got a formula that I provided here. So it says F equals P 1 plus I to the power of N. So F is future, P is present, 1 plus I to the n. So part of what you repay in year 5 is because of the 10,000 you get today, And part of what you repay is because of the $5,000 that you're getting a year from today. So you could say, in a way, this F line has two components. It's got the component that was contributed from the $10,000, and it's got the component that's contributed from the $5,000. So the total future repayment would be the sum of the two pieces. So I will be the same for those two pieces, but N is different. So let me leave it there for a second. Let me see if you can figure out how to find the total future value that you're going to have to pay back. Okay, so counting the number of years between two different arrows is important. So the $10,000, how many years into the future is it moving? So let me count. 1, 2, 3, 4, 5. It's moving 5 years into the future. N equals 5 to find the future equivalent of that present value. Oh, I should have written 10,000 there for the second one. That's actually just me writing too quickly. So on the second one where it says 10,000, that should be 5. I think the number's right though. The 6312, that's correct. But I should have written 5,000. But the main thing is, what is N? We'll count how many years into the future is it compounded. 1, 2, 3, 4. So N is different for that second arrow because it doesn't have as many years into the future where interest is compounded.
Is it the same?
That's a 6. Yeah, I got chicken scratch, and you're going to learn that for sure. Hey, before you go, I've still got 2 more minutes. So let me walk you through the statement at the bottom. Cash flow diagrams are often put together after you have words. Sometimes you need to write the statement based on the cash flow diagram. You need to be able to translate both ways. So you receive 10,000 today, then you receive 5,000 in one period. You should pay $19,694.64 at the end of 5 periods from today at 6% interest per period. So it never said years. That's why I said per period rather than per year, just to reemphasize that. So remember, that's actually a misprint. It should have said 5,000 there. Sorry for the mistake. Anyways, that's all for today. If you came in late, let me know so that I could give you partial credit for attendance. And I will see you on Wednesday, not next week, week after next. Thank you.
Yeah, maybe.